Compound depreciation, or depreciation on a reducing balance. Recall the formula for compound growth that we learnt in grade 10. In compound growth, such as in compound interest, the interest rate is applied on the revised value of principal, which is the original amount and the interest on it. In compound decay, such as in compound depreciation, depreciation rate is applied on the revised value of the asset, which is the original value less depreciation. Compound decay, or depreciation on a reducing balance, is the opposite of compound growth and is given by the formula. In compound decay, such as depreciation on a reducing balance, the value of depreciation is calculated as a percentage of the reduced value of the asset. The book value of the asset at the end of the year becomes the principal amount for the next year. The value of depreciation changes every year and is not constant. It is higher in the initial years and gets smaller as the life of the asset progresses. Mathematically, the value of the asset will never get reduced to zero, as the depreciation is always charged as a percentage of the reduced value. The asset will always have some value. Let us explore these concepts in more detail using an example. Melanie, a branch manager at a digital printing store, purchases a fast, heavy-duty laser printer for 40,000 Rand for her store. What will be the estimated residual value of the printer? If she wishes to replace this printer after 5 years and adopts a reducing balance method of depreciation at the rate of 25% per annum, use a graph to show the value of the asset over the 5-year period. Solution. Let us note down the given data. Melanie purchases a printer for 40,000 Rand. So, P equals 40,000. We are asked to find out the estimated residual value. Residual value means the depreciated value. So, we need to calculate A. The residual value is to be calculated at the end of 5 years, as she wishes to replace this printer then. Therefore, N equals 5. The method of depreciation is reducing balance, and the rate is given as 25% per annum. I equals 25 over 100 equals 0,25. Recall the formula for depreciation on a reducing balance. Using this formula, we can calculate A. Substituting the values of P, I, and N in the formula, we get, therefore, A equals 9,492,188 Rand, which can be rounded to 9,492 Rand and 19 cents. Now, to plot the value of the asset on a graph over a 5-year period, we need to calculate the value of the asset at the end of each year. Let us use a table to write down the values at the end of each year. We know that in compound depreciation, the value of depreciation is calculated as a percentage of the reduced value of the asset. I equals 0,25. Hence the rate of depreciation, I, will be applied on the value of the asset at the beginning of each year. For year 1, the depreciation will be 0,25 times 40,000, which is 10,000 Rand. Therefore, the depreciated value at the end of the first year will be 40,000 less 10,000, which equals 30,000 Rand. Alternatively, we can use the formula for compound depreciation and calculate the value of A directly by substituting the value of N equals 1. Recall that the book value of the asset at the end of the year becomes the principal amount for the next year. Hence, 30,000 Rand becomes the principal amount, or the value of the asset at the beginning of the second year. We now calculate the depreciation amount for the second year. We find that the depreciation amount has now become 7,500 Rand, and the value has reduced to 22,500. Again, if we had substituted the value of N equals 2 in the formula, we would get the same answer. If we continue in this way, we can calculate the value at the end of each year. Observe that the value of depreciation changes every year and is not constant. It is higher in the initial years and gets smaller as the life of the asset progresses. Also, note that the value of the asset at the end of the 5th year that we have derived now using a step-by-step approach matches the answer that we calculated earlier for the residual value of the printer using the formula. Let us now plot the values on a graph. Key observations. The graph is not a straight line, but is actually a curve-shaped graph. It is a graph of an exponential function, where y equals a times b to the power of x, where b is less than 1. Initially, the curve is steep, and thereafter, as the amount of depreciation slows down, it becomes flatter. This method of depreciation is hence applied when the asset is likely to become obsolete quickly due to technological advancements. For example, for depreciating computer equipment, this method is often used to ensure that high depreciation is charged in the initial years of operation.
Need more help? Subscribe to our channel. Can't wait that long? Ask Masky to help you and let the math finally start mathing.